Hi, welcome back, everybody. Today we are going to be talking about how to graph polar equations for pre-calculus. So let me go ahead and pull up this piece of paper over here. The objective, again, as I said, is to figure out how to graph polar equations. Just like we do with Cartesian equations. And preferably, I would like to not go back and forth between polar and Cartesian if possible, but just strictly stay on polar because the conversion just takes too much time. But for the sake of showing examples, I will go ahead and do that for the first maybe a couple of them just to verify the answers. So here are some examples of what we deal with in polar equations then. So we have in the first case, theta is equal to 135 degrees. So what that means is no matter what r is, theta is always going to be equal to that value. And if we kind of compare that to, again, how Cartesian work, it's kind of like saying x is strictly equal to 2 or y is strictly equal to 4. So the graph is going to be something that's kind of unique then. Now, where is the line, or where is 135 degrees? Well, that is located right here, if you can kind of see it on the polar graph then. So then that means no matter what I graph, theta is just always equal to that value. So to me, graphically, then that means the answer is just going to be a straight line going down that direction. So here is going to be my graph. So that's what it looks like then. And remember, the idea here is that theta, so long as it's equal to 135 degrees, r can be equal to whatever it wants. R can be equal to 2, r is equal to 3, r is equal to 5, r is equal to negative 10, and so on and so on and so on. So then that is the conclusion then. Now, as I said, I'm going to go ahead and try to change this back into Cartesian so you can kind of verify the answer. From the previous sections, we know the following substitution. We know x squared plus y squared is equal to r squared. We have x is equal to r cosine theta. And then we have y is equal to r sine theta. And then finally, we have tangent of theta is equal to y over x. So what I'll do is with our equation, let me go ahead and take the tangent of both sides, because then I can introduce something that's up there. So that is taking the tangent of both sides. Tangent of theta is equal to the tangent of 135 degrees. And as soon as I do so, you'll notice that tangent of theta, I can do a replacement with y over x. So that's y over x is equal to the tangent of 135. That's something that's on a unit circle that we should know, which is negative 1. And now if we go ahead and change all of that, so that's y is equal to, you can see now it's going to be the line y is equal to negative x, which is basically what I just graphed. Okay. So for the time being, at least, for this next section or so, if you are very uncertain or if you just want to verify your answers, you can go back and change it into Cartesians. But later on, we will try not to do this anymore if possible. Okay. Now, let's go ahead and try to graph r is equal to 4. Now, for r is equal to 4, again, it's the same idea as theta is equal to a number. So that means the graph in this case is going to be somewhat unique also. R stands for radius. So that means your radius is always equal to 4. And doesn't matter in this case what theta is equal to. Those are your only two variables. You don't actually have anything else. So in this case, let's go ahead and find the ring that is of radius 4, and that's basically going to be my graph then. So here you can see that I'm just going to find that, and it looks like it's going to give me a circle, and in fact it should be a circle because again the radius is equal to 4. So that is going to be my graph for r is equal to 4 then. Again, just go ahead and change it back into Cartesian just to verify my answer for those of you guys that are not familiar. Let's see, in terms of which substitution over here, I don't see one that is direct, but in a way I kind of do. I can actually choose the first one over here because r is what's going to lead me out of the polar. If I replace r with something that's in terms of just strictly x and y. In terms of what's the replacement, according to my equation up there, I'm going to replace r with the square root of x squared plus y squared. So square root of x squared plus y squared is equal to 4. And now if we square both sides, we can see x squared plus y squared is equal to 16 then, which is again a circle with radius of 4, which is what we drew, and also the center is located at 0, 0. Okay. Now let's look into something that's a little bit more complex. I'm going to try to use just strictly r and theta first to try to solve for this. Okay. Now, r is equal to 10 cosine of theta. This one is a little bit more complicated, but, it's still doable. So the best thing about polar, in terms of like how to graph it, what we want to do is we treat it just kind of like what we did with x and y when we first learned how to do graphing in Cartesian. That is to say, make a chart if we don't know what it looks like. So that's what I'm going to go ahead and do then. So for my values of theta, which is my independent variable, and r, which is my dependent variable, it's kind of like y in this case, we're going to select theta, and then we're going to try to solve for what r is equal to. Okay, so let's go ahead and select a few, and then that way, hopefully, we can kind of predict the graph. So let's go start with 0 degree, because that's probably the easiest. 0 degree plugged in, we get 10 multiplied by the cosine of theta, where it's supposed to be 10 times the cosine of 0 degree, so that is strictly equal to 10. Now, if we try 45 degrees, we're going to get 10 multiplied by the cosine of 45, which would then give us 10 multiplied by root 2 over 2. So the answer is equal to 5 root 2. Taking, let's see, a few more, as many as you need to. Let's see, at 90 degrees, you are going to get 10 multiplied by the cosine of 90. And then that would give you 10 times 0, which is equal to 10 then. 10 times 0 is not equal to 10. It's equal to 0, actually. So sorry about that. Oh, bless you. Maybe allergy season's coming up. Okay, so that's equal to 0 then. Let's see. How about this time 135 degrees? 10 multiplied by the cosine of 135. That will give you 10 multiplied by negative root 2 over 2. So that gives you negative 5 over 2. And you'll notice that I'm not trying every single value that I know on the unit circle because I want to minimize, how much work I also do too. Later on, we can actually just try the multiples of 90s once you get the grasp of this instead of like multiples of 45. This is just an example to show you how it actually looks then, one small step at a time. Continuing it on, 180 degrees. Then we have 10 multiplied by the cosine of 180, and that is equal to 10 multiplied by negative 1, so the answer is equal to negative 10. So let's just go ahead and take a look at what we have right now so far. At 0 degree, we're going to be at 10 for the radius, so that means we're going to have a point that starts all the way out here. At 45 degrees, your radius is equal to 5 root 2. 5 root 2, that is going to be, let's go ahead and take a quick look at that approximation. So here, we'll go ahead and use graphing calculator. So 5 and then root 2, so that is approximately 7.071, okay? So going back here, let me just kind of make that quick note, 7.071. So that's going to be our radius. So on the R, we're going to go up by that amount. 1, 2, 3, 4, 5, 6, 7. So somewhere maybe over here then, as an approximation. When you get to 90 degrees, you're going to go back to 0. So that means that you're going to go to the origin, or what they call the pool in this case, for the polar graph. Okay. Now, I'm going to go ahead and make the connection between these 3 dots, so then that way you can see what it's supposed to be like. From 0 to 90 degrees right here, you'll notice what's happening is that r is decreasing. R is decreasing from 10 to 0, so that means your radius is getting smaller and smaller. If it helps, maybe what we can do is make one substitution in between, so then that way you can see where is it going then. So maybe at theta is equal to 60 degrees. So I'm just going to go ahead and do that on the side. R is equal to 10 multiplied by the cosine of 60 degrees, which is the same thing as 10 times 1/2. So that would give us 5 then. So at 60 degrees, we're going to go to 5 as a radius. 1, 2, 3, 4, 5. So that's somewhere around here. And now if I connect them, remember what I said, as you rotate from 0 to 90 degrees, your value of r is decreasing from 10 to 0. So what that tells me is that you're probably going to do something like the following right here. So that's going to be just kind of like a sketch of the curve. And it turns out that, yeah, this is actually a circle. But for right now, let's just say that I don't know, and all I'm doing is just connecting the points, and that's technically okay for the time being. Okay. Now, continuing on from 90 to 180 degrees. At 90, we start at 0. So again, we're going to be at the pole at the moment. At 135 degrees, now again, here's 135 degrees. My radius is negative, so that means it's negative 7.071. I'm not going to go out in the direction of 135 because that's when r is positive, but instead, it's going to be going out in the opposite direction because r is going to be negative. So that means my next point is going to be down here, kind of like going towards 315. 1, 2, 3, 4, 5, 6, 7. And that's because, again, r is equal to negative 7.071. Well, if I plug in theta is equal to 120 degrees, just again as another point of reference, r is then equal to 10 cosine of 120, which is equal to 10 times negative 1/2, so it's equal to negative 5. So that next point is going to be at 120, and we're going again in the opposite direction. So 1, 2, 3, 4, 5, which is going to be down here. Let me go ahead and erase some of these guys over here just so that we can see it a little bit better. Okay. But again, you can probably imagine what's going to happen at this point then, because we're going to be connecting those points. And finally, looking at our last point of connection at 180 degrees, you have a radius of negative 10. So for 180 degrees, we are going to the opposite direction, going backwards as if we're going to 0 degrees, and we're going back to 10, which is basically going to be a starting point. So the 4 points that we're connecting would be right here, okay, right here, right here, and right here, which is going to look like the lower half of the circle that we just created. So that is going to be our graph then. Okay. Now, just to show you how this kind of work out, another perspective of looking at it, if my radii were positive, then that means the graph would probably look something like this then, okay? But because all my radii from 90 to 180 degrees are negative, then that means I'm graphing in the opposite direction. And so that red portion of the graph, the opposite of it or the negative of it, you can see that that's a reflection of the pole. You're going to, you're going to kind of like take that arc of the red, reflect it about the x-axis, and then reflect it about the y-axis in order to get what I get. So let me go ahead and erase that guy right there. Okay, so that is going to be kept for next time. And now if we try to finish off the rest of it, because normally we go from 0 to 360, you can go ahead and do 225. And let me change this a little bit. Okay, so 225 you solve for r, which is going to be again 5 root 2. 270, that comes out to be 0. 315, that comes out to be negative 5 root 2. And then 330, 360, that comes out to be, let's see, it's equal to 10. Just to kind of save you a little bit of time, because we are trying to, well, I mean, the calculation part, that shouldn't be too bad. But what ends up happening is that the second half of what we're trying to plug in, it turns out that we're just going to repeat the circle one more time. So because it's a repeating part, you don't really have to much graph because it's exactly the same thing. So that is going to be the sketch of our graph for r is equal to 10 cosine theta. Okay. Now, let's try to identify this graph for future references, so then that way we don't have to kind of reinvent the wheel every single time. Note that for this circle, I have 10 right here multiplied by cosine of theta, and that 10 is actually the diameter of the circle in this case. Okay, so right here, let me kind of write that out. So that 10 is going to be the diameter of the circle, okay? The cosine is actually kind of like giving me the direction as to where that circle is actually going to go. This cosine of theta right here tells me it's going out in the x direction. The circle is going out in the x direction. Okay, let's do this. Again, let's do it one more time, changing it back into x and y. So then after that, we're not going to actually ever do that again, okay? So what I'll do is I'm going to go ahead and erase all of this. So hopefully you guys were okay with what I had earlier. Okay, so if you missed that part, just go back to the old video, but I can't do that, unfortunately. Okay, let's make a substitution then, okay? We want to change r and theta back into x and y so you can see that that's actually what we have, a graphing of a circle. What I'm going to do is I'm going to go ahead and do something a little bit different, just like before. I'm going to multiply everything by r, okay? So multiply both sides by r. So we'll get r squared is equal to 10 times r cosine theta. And that's actually a very common trick in polar in order if you want to do a conversion from polar to Cartesian, because that would give us r squared, which is something that's an easy direct substitution. And that would also give us r cosine theta, which is directly also equal to x. So according to what we have, right, the substitution is going to be r squared is equal to x squared plus y squared. And we are going to take r cosine theta and replace it with x then. So over here, we have x squared plus y squared is equal to 10 times x. And that hopefully looks a little bit familiar to you because that's kind of like a form that is of an equation of a circle. Moving everything over to the left-hand side, we get x squared minus 10x plus y squared is equal to 0. Completing the square, we get x squared minus 10x plus 25 plus y squared is equal to 25. Completed the square, that's what we get on the left. And again, as we said, there's your equation of a circle, which tells us the center is located at 5, 0, which is exactly where we have right here. Okay, and your radius is equal to 5. And so that comes out to be exactly what I was saying earlier, right? Your 10, that number's multiplied by the cosine, that is just going to be, whereas the cosine of theta, that tells me that it's the circle is going out into the x direction then. So that is something that's kind of useful because now we have an idea about this general equation. R is equal to a cosine theta, or R is equal to sine theta. So we can maybe make that conjecture for this one over here. So let's say we have R is equal to negative 10 times sine of theta. So again, just going by what we've been doing so far, I'm going to go ahead and create a chart just so that you can see what's happening. But hopefully, if we go by the previous example, we can also quickly see what the graph is going to be like. Okay, so let's go ahead and do that then. We're going to go ahead and use theta is equal to 0. We're going to use the values of theta, and then we're going to solve for what r is equal to. So we'll go ahead and use 0, and then 45, and then 90. 135 and then 180, and we'll go ahead and stop right there for the time being. Just solve for these first. So let's see. For the first one, theta is equal to 0. That's negative 10 multiplied by the sine of 0 degree, which is going to be equal to 0 then. 45 degrees, you get negative 10 times the sine of 45. That is equal to negative 10 multiplied by root 2 over 2. So that's equal to negative 5 root 2. 90 degrees, we get negative 10 times the sine of 90. So that gives us negative 10. Negative 10 times sine of 135. That is negative 10 times positive root 2 over 2. Okay, I almost made a mistake there. So that's going to be negative 5 root 2 then. And finally, for the last one, negative 10 multiplied by the sine of 180 degrees. That is negative 10 multiplied by 0, which is equal to 0. So again, we have these negative values of radius, so we have to be very careful here. This time, I'll go ahead and use the graph in red, but I'm going to go ahead and use the same polar paper just so that we can save a little bit of space, I guess. Or actually, we can also compare to the previous graph. We start at 0 degree and radius of 0, so that means we start at the pole. Now, for 45 degrees, my radius is going to be negative 5 root 2. So again, we're going to go in the opposite direction of 45 degrees, and we're going to go in towards the 225 degrees, out towards that direction of 5 root 2 then. So that's 1, 2, 3, 4, 5, 6, 7. So that graph, that point is somewhere over here. And again, just for reference sake, if you remember, in the last section or before, we said that if you have 45 degrees, comma, negative 5 root 2, okay, that right there, the graph, the point, is the same thing as 225 degrees, comma, 5 root 2. In terms of positions, these two are basically at the same single point, okay? So that's why they can be interchangeable. All right, next part, 90 degrees, you're going to get a radius of negative 10. So that means at 270, we are going to go out in the 10 direction. So that means it's going to be somewhere over here. We're going to connect those 3 points. So once again, we'll go ahead and maybe grab one more point just for our sake, curiosity, because I want to make sure that I'm doing it correctly. Let's go ahead and use theta is equal to 30 degrees. Okay, so theta is equal to 30 degrees. The idea is use as many points as you need to, again, to figure out what the graph looks like, and then afterwards build off of that so that you don't have to do it every single time. When theta is equal to 30 degrees, r is equal to negative 10 times the sine of 30 degrees. And that's negative 10 multiplied by 1/2. So the answer is equal to negative 5. So at 30 degrees, we're going to go backward towards 210 in the opposite direction. And we're going to go to radius of 5 then. So 1, 2, 3, 4, 5. So this is going to be our point then. So looking at our 4 points to connect for the red, you can probably see what's going to happen then. It's going to be very similar to what we did earlier. So that will give us probably something like this. Okay, so that is going to be the curve of the graph. And I'm going to go ahead and draw some arrows so then that way you can see where the graph is actually going towards, because the path of this polar is what's going to lead us into, I guess, our future section on parametric equations. Okay, second half of this from 180 to 270 degrees. I think, again, you have the same idea as before. So let's go ahead and try some more values just to see what happens then. So we have 225, we have 270, then we have 315, and then we have 360. So 225, let's see, that's going to be negative 10 times the sine of 225 degrees. So that's negative 10 times negative root 2 over 2. So that is going to be equal to 5 root 2. At 270, if I plug everything in, just to kind of shorthand a little bit, because, I want to save a little bit of time, I'm pretty sure the answer is going to come out to be equal to 10 in this case. Next one, at 315, you're going to get, looks like it's going to be 5 root 2. And then finally, the last one at 360 degrees, you're going to get 0 then, okay? So let's see, taking those values and plugging in. 225, 5 root 2, let's see, is that, where is that going to be then? 225, 5 root 2, is that correct? Let's see, putting in, yes, looks like it's okay. I might have, I see what happened. We only graphed this portion over here. So now we actually have to continue on with this portion. So that's where my mistake was. So I apologize for that, okay? At 90, negative 10, that's going to be this point over here at the 270, positive 10. We now go to 135, negative 5 root 2. So 135, negative 5 root 2 in the opposite direction. That's going to be this blue guy over here. And then at 180, 0, that's going to get us back into the origin. So that means that your curve is going to go out this way. And without having to do 330 again, or actually 150 again, I'm pretty sure that it's going to look something like this then. Okay, so that is the second part of the curve from 90 to 180. And again, it's curved, it's graphed on the opposite side because the radii are negative. So I think we can probably make a good conjecture as to what's going to happen now, because afterwards, the values that I wrote out from 180 to 360, you can see that the radii are going to be positive. So you're just going to go back into that same circle to create the same circle once again. And because it's the same path and everything, we don't even bother graphing it then, because we have the actual graph. But more importantly, trying to get something that we can build off of in the future, if you have, again, r is equal to negative 10 sine theta, again, that 10 right there, it looks like that is going to be, again, the diameter of the circle. Okay. So that's exactly what's happening here. And again, the sine right there, the trig function, that tells you which direction you're going to go towards, which in this case is going to be the y direction, okay? And the negative tells you that you're going into the negative y direction then. Because remember, when it comes to polar, right, x is related to cosine, whereas y is related to sine, just like you did on the unit circle, okay? So hopefully that part does make sense. If you want to convert that back into Cartesian, you can definitely see what the equation is. But my guess, according to what we've been saying so far, is most likely you're going to get the equation x squared plus y and then plus 5 squared is equal to 5 squared then, okay, according to what we said. All right, so to kind of like make a conclusion, I guess, if we have r is equal to a cosine theta, or r is equal to a sine theta, the conclusion that we came up with is that the a value, right, that is supposed to be the diameter of the circle, okay? And then the cosine right there and the sine right there, that tells you that the circle is going out in the x direction, whereas if it's sine, then it's going out in the y direction. Okay? All right. So let's go ahead and look at a few more examples, and then I think we'll go ahead and call it. So for the first part, sine theta. So now we're treading into another general form of the equation of the polar. We're looking at specifically r is equal to a plus b cosine theta, okay, or minus b cosine theta. Okay, let's try not to be long-winded for this one, but I want to make sure that you guys are seeing this. So what I'll do is, again, I'll create a chart, but we now have a better idea about this chart. So what I'll do is let's make it a little bit easier this time. Let's say now we're only going to use multiples of 90s because we get the idea as to what's happening with the curve each time. Let's see. So I'm going to go ahead and look at 0, 90, 180, 270, and then 360. And again, if you need to plug in more values, we can go ahead and do that. But I think we can actually work off of what's here because, well, these numbers are actually pretty nice. So let's see, 0 plug into r, 0 plug in for theta. So that's 6 plus 3 times the sine of 0 degrees. So that looks like it's going to be 6 plus 0, which is equal to 6. At 90 degrees, we have 6 plus 3 times the sine of 90 degrees. That gives us 6 plus 3, which is equal to 9. Next one, 6 plus 3 times the sine of 180. That is equal to 6 plus, let's see, it's 0. So that's equal to 6 over here. 6 plus 3 times the sine of 270. That gives us 6 minus 3. So that's equal to 3. And finally, 6 plus 3 times the sine of 360 degrees is going to equal to 6 plus 0. So the answer is equal to 6. Okay, so nice and clean value of theta r for the time being. So let's go ahead and find those points on the polar graph then. 0, 6, that is located right here. 90 at 9, so that means it's going to be located somewhere over here. And then 180 and 6, so that is going to be out here in the left-hand side. So 1, 2, 3, 4, 5, 6, so that's somewhere over here. Again, we'll just go ahead and take care of this part first for the graphing, and then afterwards we'll look at the other one. So the radius is going to start at 6, and then it's going to expand out to 9, and then it's going to decrease back to 6 then. So as a curve, your radius is going to increase from the first blue point that we have over here to the second blue point over here. So the curve of it, again, this is just a sketched curve, is going to look something like the following over here. Okay, so that's going to be our curve. Actually, let me just go ahead and make this a little bit better, because the way I drew it, it looks like the radius is actually decreasing. So here's 6, right? We're going to draw it so that it's going out, right, as the radius is getting bigger and bigger and bigger, okay? And then afterwards, it's going to get closer and closer to 9. So it's going to look something like this then, okay? Now, in terms of the curvature, how do you know that it actually goes outside? We actually don't for the time being. But so we just get an idea as to, like, what's happening for time being, for right now, okay? So this is just a sketch. Let's see. So this is going to look something like this. And then next part, from 180 to, from 90 to 180 degrees, your radius is now going to be going back from 9 to 6. So to me, that is saying that the next portion that I'm graphing is supposed to be a reflection of the previous part, which is what I just graphed, about the y-axis. So that is going to look maybe something like this, okay? So here you can see that it's going out this way, this way, this way, and then this way, and then going out this way, okay? Let's see. From 180 to 270, your radius is going to go into 3. So let's see, how does that work out? 270, we're going to have a radius of 3, so that's going to be somewhere down here. And then afterward, 360, 6, that's going to go back to our very starting point, which is this guy over here on the right-hand side. So the curve of the graph, you're going to go out from this point down to this point, okay? And then afterwards, you're going to go out from this point all the way out back into this point, because that, again, is symmetric to what I just graphed in the third quadrant. So the sketch of the graph looks kind of like a circle, but it turns out that it's actually not a circle in this case. It's actually kind of like a lopsided circle. If I graphed it a little bit better, it probably looks something kind of like this. It's almost like a one of those, like, jelly beans, or not jelly beans, but like whatever those candy that you used to eat when you were younger. The one that shapes kind of like a like some sort of jelly. Okay. Just to verify what I graphed, let me go ahead and show it to you on the graphing calculator. Let's go ahead and change the mode to a let's see, where's that guy right there? Does it allow me to do that? R is equal to cosine theta. Where is the polar function? Parametric polar. Here we go. And I am going to go and keep it in radians. So let's see. We said it's 6 and then plus 3 sine of theta then, okay? Make sure that my values are going to match up, and it does. So let's see the graph. Oh, that's not right. Let's see. I am supposed to graph in polar, but why is it showing parametric? Let's see. X is equal to, let me go ahead and trace this guy right here. Something is strange. Well, I'll get back to it sometime when I figure it out. But actually, no. We'll stay away from decimals for the time being. Okay. All right. So anyhow, just gonna have to take my word. Yeah, that's basically what the curve is going to actually look like in this case. Then, okay. So in terms of like how do we characterize this? We really can't for the time being, because this is a really, really weird shape. It's not something that we're used to, again, comparing back into Cartesian. And in fact, if we take this equation and change it into Cartesian, it would just be a big mess. And so we would try to stay away from that if possible. Okay. Let's see. Let's try now a different, one last type of problem. And then I think we can go ahead and kind of end it afterwards, okay? So this is just going to be the last one where we're going to just kind of plug in to see what happens. So let's see. We have 0, we have r. So we're going to go ahead and plug in values of theta, so then we can figure things out. I'm just going to use the values of 90 degrees, multiples of 90s, but if you want to use other ones, that's totally fine too, okay? So let's see, we're going to go ahead and use 0, we're going to use 90, and then 180, and then 270, and then 360. And again, you use whatever values of theta, which allows you to see the graph after you connect those points. So let's see, 0 you plug in, you get 4 divided by 2 plus 2. So that is going to give you 4 for that part of the answer. The next part is going to be 4 divided by 2 plus 0. So that's going to give you 2 for the answer. 4 divided by 2 minus 2. So this is going to be undefined right here. Okay, and in fact, it looks like it's going towards positive infinity. So we'll take care of that in just a little bit. Let's see, 4 then divided by 2 plus 0. So that is going to give us 2. And finally, 4 divided by 2 plus 2, so that's going to give us 4. And keep in mind that 360 is the same thing as 0, so we should actually get the same answer for the R for the most part, okay? Unless there's like some sort of weird modification. Okay, so here we go. 0, theta is equal to 0, R is equal to 4, so we're going to find that point. That's out here. 90 is equal to 2, so that's going to be this guy over here. 180 is going to be infinity, so that means that the radius is going to be just a really, really large number. Now, in terms of connecting, how do you actually connect that? First, I'm going to take the first point, connect it to the second point, right, with like a kind of like a slight curve. And remember, as thetas are going to 180 degrees, you're going to go towards infinity, going towards this way. So my guess is that the curve is probably going to go out like something like this then. Okay, maybe a little bit wider, probably is a little bit wider, so it's probably going to be something like that then. Okay, so let me go ahead and erase parts of it, and there you go. So that's going to be kind of like it's just a rough sketch of our curve then. Okay, and later on again, we'll have like a better idea as to what this curve is going to look like, so that when we generalize it. Now, let's see, from 180 to 270, what's happening is we're graphing in the third quadrant over here. And your radii, we're going to come back from infinity, and you're going to go to 270, 2, which is going to be this point. So to me, it's going to be kind of like symmetric to what we just graphed right here in the second quadrant. But now it's going to be down in the third quadrant. So your sketch might be something like this. Okay, so it's going to go up across this way, going to go back this direction. And then finally, from 270 to 360, which is in the quadrant 4, we're going to go from 270, 2, which is down here, back to 360, 6, which is the original point. So that is going to be this right here. So that is going to be my sketch curve. Okay. So that is going to be the conclusion of it. Okay, so for right now, again, all you're doing is just plotting in values of theta, so in that way you can figure out what R is, and then finding those points on the polar graph, so you can get a sketch of the graph then. Okay, do you need to generalize like what the shape actually looks like? It'll be nice if you can, but for right now, just try to get the feel of how do you get the curve first by just plotting in points. Okay. All right, so I will talk to you guys later and have a good time.